5.3, we're working with when is a function increasing and decreasing, and relating that to the first derivative. So let's first find all the critical points of the graph of f. And critical points, again, is when f prime is equal to 0 or f prime does not exist. So at this graph here, right here is where there's a horizontal tangent line, f prime is 0. Right here, the first derivative is equal to 0. And at this point, the first derivative does not exist. When the slope of a function is positive, the function's increasing. When the slope of a function is negative, the function is decreasing. So let's look at this here. From negative infinity on this graph all the way up to positive 3, you see the function here is increasing, so the derivative is positive. So you start from the very left, which is negative infinity to 3. Sine of f prime of x is positive because the original function's increasing. And then at 3, x is 3, f prime is just 0. And then let me just put the rest of these points here. The 5 here is also 0 when x is 6, d and e. You want to write these out every other, just so you can get the intervals in between them. So from 3 to 5, see from 3 to 5, the function is decreasing, therefore the first derivative is negative. From 5 to 6, you see the function is increasing, therefore the slope is positive. From 6 to infinity, the function's decreasing, therefore the first derivative is negative. Be very careful, guys, because increasing and positive are different. Negative and decreasing are different as well. Find the intervals on which the function f of x equals negative x squared minus 4x minus 1 is increasing and decreasing, and justify your answers. So if they're asking when's the function increasing or decreasing, you should think the first derivative. First, what you want to do is find the critical points. So calculate the first derivative and set it equal to 0. F prime of x is equal to negative 2x minus 4 equals 0. You solve for x, you get x is equal to negative 2. In between the x values, the derivative must be positive or negative. So if we draw, there's only one critical point here, right? So we should have 3 columns here and just have the negative 2 in the middle, because we want all points to the left of negative 2 and the interval that captures all points to the right of negative 2. So you should start with negative infinity to negative, go up to negative 2, and then start at negative 2 again, go to positive infinity. So right here, we use a chart to help keep track of the information. We did this. So you want to know the sign of f prime on the interval negative infinity to negative 2. All you'd have to do is just pick some number in between here, between really negative number and negative 2. So let's just say negative 5, because negative 5 is in this interval. We can choose anything on this interval, we will get the same result. So you see the first derivative is right here. If we plugged in negative 5, negative 2 times negative 5 minus 4, that's 10 minus 4, and that's 6, which is greater than 0. So the sign of f prime on this interval is positive. Well, at negative 2, we calculated the first derivative to be 0. Now, all we do is pick a number between negative 2 and infinity. So let's say we pick 0. Negative 2 times 0 minus 4, that's 0 minus 4, which is negative 4, which is less than 0. Therefore, f prime is negative on this interval right here. So, answer statements with justification, because they asked you find the intervals where the function's increasing and decreasing. So, f of x, or f, is increasing on this one right here, negative infinity to negative 2, because f prime of x is positive or greater than 0 on that interval. F is decreasing from -2 to positive infinity because f prime of x is less than 0. These are justifications that you have to know anytime you solve a problem like this. You will have to memorize these. Next page here. Find the intervals on which the function f of x is increasing and decreasing and justify your answers. So if we find the first derivative, f prime of x is equal to x squared minus 2x minus 15. And we gotta set that equal to 0. Factor this out, you get x minus 5 times x plus 3 is equal to 0. And then you see we have x is equal to positive 5 and negative 3 for the critical points. So we can create the table here. Negative 3. You should always do this from least to decreasing, lowest to highest. So negative 3 and 5, and then we can write out all the intervals. Start at negative infinity, go up to negative 3. Now negative 3 to 5, and 5 to infinity. So now we have to take the sign of f prime of x. So we take this interval, and we have to pick a number here. Let's just say we pick, I don't know, like a negative 6. So negative 6, again, this is the equation. We're plugging this into f prime. What I have underlined right here is your f prime. If you plug in a negative 6, negative 6 minus 5, that's a negative number. And then over here, negative 6 plus 3, that's a negative. So you have a negative times a negative will get you a positive right here. Let me write these zeros here. So between negative 3 and 5, let's just pick 0. 0 minus 5, sorry, let's see here. That's a negative times a negative, which is a positive. So if we plugged in a 0 here, right? A 0 minus 5, that's a negative. 0 plus 3, that's a positive. A negative times a positive is negative. Again, for each of these intervals, you can pick anything that's in between. You will get the same result. So 5 to infinity, let's just say I pick 100. 100 minus 5, that's positive. 100 plus 3, that's positive. So here, the sign of f prime, that's positive. So your answer statements with justification. F is increasing on negative infinity to negative 3 and 5 to infinity because f prime of x is greater than 0. F is decreasing on negative 3 to 5 because f prime of x is less than 0. So these two examples we just did were with algebraic functions. And here we're going to do some practice based on a graph. This is a graph of f prime, the derivative, f prime. Determine the intervals where f is increasing and decreasing based on the graph of f. This is asking where f is increasing or decreasing. So if you think about this right here, right? Increasing, well, when I think increasing, f prime should be positive. So if you look at this graph here, right? Where is this graph positive? Where is f prime positive? See right here it's positive because f prime is positive greater than 0. And then you see right here positive because these are all above the x-axis. So increasing on the interval negative infinity to, is that a negative 3? And 1 comma 3 because f prime is greater than 0. So decreasing is just vice versa. Where is f prime less than 0? That's from negative 3 to positive 1, and 3 to infinity, because f prime is less than 0 here. So, application problems of rates of change. If you want to know if something is increasing or decreasing, you look at the sign of its rate of change. The sign of a rate of change can tell you if the dependent variable is increasing or decreasing. So example, if the rate of change of students per year is positive, that just means the number of students is increasing, because the rate of change of students per year is positive, so the total number of students is increasing. If the miles per hour is less than 0, the number of miles is decreasing, because the rate of change is negative. If the rate of mastery checks per week is greater than 0, then the number of mastery checks is increasing. Noticing the pattern here? If the virus cases per month squared is less than 0, it's a squared here, so that means the rate of virus cases per month is decreasing. And because it's the month squared here, that's why this is a rate instead of the number like all these other problems. So here's a really tricky problem here. 4. The rate of change of fruit flies in Mr. Kelly's kitchen at time t days is modeled by r of t equals 2t cosine t squared flies per day. Show that the number of flies is decreasing at time t equals 3. So notice here, r of t is already the rate. If this is already the rate, so all we have to do here is just plug in 3. If you do this on a calculator, you would get a negative 5.4667. A common mistake, because this sometimes comes up on the exams, AP questions too. Some students might make the mistake of doing r prime of 3 here, which sometimes you would. But in this case, you don't, because r of t is the rate. If r of t was the number of flies in Mr. Kelly's kitchen, then you would have to find r prime of 3 and determine whether or not that's positive or negative. But r of t is already the rate, so you do not need to do this. So you have to read problems very, very carefully. So because r of 3 is less than 0, so number of flies is decreasing. Again, I'm going to emphasize one more time. If this problem had stated r of t is the amount of fruit flies in Mr. Kelly's kitchen, then you would have to do the derivative r prime of 3 and figure out if it's positive or negative to determine your answer. But in this case, you do not need to find the derivative because r of t is already the rate of change. You can go ahead and start the practice.